Today we're going to talk about how to convert from standard form of a linear equation to slope-intercept form of a linear equation. Well, the standard form of a linear equation is ax plus by equals c, where a, b, and c are constants, just numbers, and these are your normal x and y variables, the x and y, like you would have an xy coordinate on a graph, just like normal. Not every linear equation you see will be written in slope-intercept form. Sometimes you'll see them in standard form, and it's easier to graph and deal with if you have them in slope-intercept form, because if you remember, it gives you the slope and the y-intercept. So sometimes it's nice to just convert them. So before we look at how to convert something like this, let's look at a regular equation where we're solving for y. Y is the only variable. We need to solve for y, and it looks like this. You'll notice that this looks very similar to standard form. That's why we're looking at it first. What will we do if we're solving for y? Well, first things first is we got to take care of this guy. So if we subtract 4 from both sides, that's 0. We're left with negative 2y on this side. 16 minus 4 is 12. And then solving for y, I need to divide by y's coefficient, or the number in front of y. Because negative 2 divided by negative 2 is just 1. And we're left with 1y. 12 divided by negative 2 is negative 6. It looks incredibly similar when we're converting from standard form. As you can see, this is almost the exact same thing we just did, except we have variables here. So we still need to solve for y. Slope-intercept form is y equals mx plus b. So you can see that that means we need y over here by itself. So same thing, I need to get rid of this 3x. I can just subtract him. Something I have to be careful about, this is 3x minus 3x is just 0. We're left with negative 2y on this side. This is what I have to be careful about. I can't take x's away from 16 from numbers. These are x's, these are numbers. They're not like terms. So I'm just going to put negative 16 minus 3x. I can't combine them. They have to stay separate. These are x's, these are numbers. So I have a coefficient in front of y, which is a problem. If I divide by negative 2, that's 1y over here. And remember that we need to divide the entire side. Whenever you're dividing or multiplying on both sides, you must do it to the entire side. So I have negative 16 divided by negative 2 is a positive 8. And negative 3 divided by negative 2 is a positive 3 over 2, x. You'd say, oh, Mr. Duncan, it doesn't look like this, but of course, addition is commutative, so I can write it in any way. 3 halves x plus 8. Y equals 8 plus 3 halves x is the same thing. These are the same thing. A couple more quick examples. Again, we're solving for y, so let's subtract over x. Negative 3y on this side. I can't combine these, so I have 6 minus x. Let's divide by negative 3 on both sides. This is 1, left with 1y over here. 6 divided by negative 3 is negative 2. Negative x divided by negative 3 is a positive 1 over 3x. And y is a third x minus 2. A couple more real quick. Subtract over 13, x. We're left with 11y on this side. Negative 13x minus 12. We can't combine those, of course. Let's divide by negative 11. That is 1y on this side. And we have 13 over 11x minus, or plus, since it's negative divided by negative, 12/11. Don't be afraid of those fractions there. This just means your y-intercept is 12/11 and your slope is 13/11. One more. Let's subtract over 4x. We're left with negative y on this side. 1 minus 4x. Oops. The coefficient of y cannot be -1. Let's divide by -1. This is y over here, and this just flips the signs. So I have -1 plus 4x, or the same 4x minus 1.